So we're looking here at the enthalpy of reaction between magnesium and hydrochloric acid. So we are going to use a data probe here. So this is our data probe. So this is a temperature probe that we're going to have a Bluetooth connection to the data logging software that we've got here. So to set this up to start with, if you can see on here, so we are going to connect to a sensor. So we need to go with sensor data there. We have got our temperature probe here, so we've got our wireless temperature sensor selected there, and we'll have a table and graph as our display. Then we can kind of see what's going on. Hopefully we'll be able to see on the screen here. Okay, so in your instructions you're told that we're going to be measuring the temperature at 30-second intervals, so we need to change the interval setting down here. So it's on hertz at the moment, so we're going to just go backwards, oops, and then we've chosen 30 seconds. So this is going to record the temperature every 30 seconds throughout our experiment. So we now need to prepare the experiment itself. Whoops, let me make sure that stands up. Okay, so I have got 50 centimetres cubed of hydrochloric acid that has been measured out in our measuring cylinder there. So I'm going to put that into my polystyrene cup. Now we're going to be reacting that with 0.12 grams of magnesium turnings. So you can see those in the weighing boat there. Now we're going to do this temperature measurements to find the temperature change in the reaction by using what we call a cooling curve. So we're going to use the temperature probe to measure the temperature every 30 seconds until we get to 2.5 minutes. At 3 minutes, we're going to add the magnesium turning. So the data probe will be logging the temperature throughout. And then we are going to carry on for a further time periods of 30 seconds until 8 minutes have passed in total. So we need to put our data probe in there. So let me just move our camera back a little bit and you can see that. So our data probe is in our polystyrene cup, and then I'm going to press start on the data logging software there. And we've got an initial reading there of 15.6 degrees. So if I take you in here, you'll be able to see that. Now we want to make sure we've got a consistent temperature throughout as well, so we'll stir from time to time as well. And at points during this I'll probably pause so you don't have to wait and sit out the time to see what's going on there. And kind of fast forward as we go along. So we're up to, what, 2 minutes 15 seconds. So I need to get myself ready to add the magnesium turnings. So remember, we want the recording at 2.5 minutes, and then 3 minutes we'll add the magnesium turnings, and we'll continue to stir as well, and then continue recording the temperature as well. So looking across our data set there for this particular experiment, we've got a static 15.4 degrees now, so we've had the 4 readings in a row. So we're almost there, 2 minutes 50. Poised, ready to check these in. There we go, so that was our 3 minute mark. Looking there, so you can see it fizzing away. So you might like to predict where you think the next temperature reading is going to be. 4 seconds to go. There we go, so that's shot up there. Okay, so we've gone from 15.4 to 25.5. Now, for the purposes of your practical write-up, you don't need to write this data down. I've got a set on the Excel spreadsheet that you can then go and have a look at afterwards. There we go, so we're now 26.7, so a much smaller temperature increase that time. And if we have a look in here, there's not so much going on now, so that's consistent with our reaction having almost reached completion there. And then our next data point is cooling off already, so 26.5 degrees now. And then we're going to continue doing this for the full 8 minutes. Okay, so we can see our data probe up there. And eyes are stirring. And I quite like having the graph showing as we're actually carrying out these experiments. So you can see the pattern evolving already. So once this has finished, we then have the full data set. What you then need to do is take the raw data, so go and look on the Excel spreadsheet that is available to you, and you need to follow the instructions on your practical sheet so that you can go and establish your own graph. You then need to add in hand-drawn lines of best fit so that you can extrapolate and find the temperature change at the point of mixing. Okay, so we want to know what the kind of maximum temperature change should have been if there hadn't been any cooling going on, and also if the reaction had occurred in a split second there, so if it hadn't taken time to release all the heat energy as the magnesium was reacting with the hydrochloric acid.